Let's look at a real life example involving exponential, and this would be growth. If you look at the example here, it's just like the one in number 4 in your book. This is actually one of the problems out of the homework assignment, so go find out which one that is. It's involving the sneakers. So we have a pair of sneakers that increase by 5.1% in cost per year. That's just in general. They're just making this generalization. So they want us to graph a function that models the cost of a $50 pair of sneakers and then estimate the cost of a $50 pair of sneakers in 25 years. So your real issue here is, first of all, getting your model written so that you can actually graph it. I would say the best thing you could do here is just use your basic form for any exponential function. So g of x is equal to a times b to the x. So your real issue then is just to figure out, okay, well, what is a, what is b, and then we can deal with the other information as we go. So our a value is our initial amount. That would be that $50. And then our b would be this growth factor of 5.1%. But remember, for it to be a growth, it has to be added to 1. So the growth is actually 1.051. So there's your function. We would put this into Desmos, and then we can answer the question. Now, you don't need the graph to make the call. What's the estimated cost for your sneakers in 25 years? You can just put that value in for x. But let's look at the function first. So we'll take 50. We're going to multiply that by 1.051. And you can put that into Desmos, and you can see, okay, well, what does this thing look like? So maybe we got 50 times 1.051, and then we're going to raise that to the x. Now you're not going to see this on the home screen because remember, this thing is actually going through clear up there at 50. So you have to zoom out to actually see, zoom out, zoom in, whatever, to see what's going on with this function. So this x value here, remember, x is going to represent the number of years. And so for you to track, well, what is it after 25 years to use the function, you're going to have to go way up there to see that. Now, you can do that. You can actually, go through that process and kind of approximate where it is that 25 is. So if this is going by tens, 25 is going to be like halfway between here. So you can look at what your cost is going to be roughly. Clear up there about $$60, 70, 80, $180 for a pair of sneakers in 25 years. So that's steep. Inflation, it's probably relatively close. I don't know. Well, if we actually use the function now, so if we go back and actually put our value in, we can see to our function, we put 25 in, so that would be the same thing as having g of 25 in this case. So after 25 years from now, and then we can do that math. So order of operations, we're going to take 1.051 and we're going to raise that to 25. And I get 3.47. Then we multiply that times 50. And sure enough, our prediction off the graph, we said about $180. The calculator gives it to us at $173.40. Steep pair of shoes right there. Shoot, those, they might even cost that much right now for certain ones. So let's just round that to 40 cents. All right, there's a working example of exponentials, how to use it involving money with a percentage growth. Percentage decay, remember, if you have money with the decay of any type, which can happen, remember that would have to be a growth factor less than 1. Okay, kids, hopefully that was helpful. You guys do well with this section. What is this? 7-1. Onward, upward. See you in the next video.